Take it away, gentlemen.
Thanks, Artis, for such decent introduction. Happy to be here, and once again, I see a lot of happy faces after the lunch break. So, Robert, happy to have you here. I hope that weather in your place is much better than in Riga currently, because it's heavy rains.
Okay, then it's better, definitely.
Okay, that's good. That's good to start with that. So yeah, so let's run a quick round of questions before we enter the discussion. So dear panelists, you can ask each other questions. Or dear audience, please, if you have any questions, just raise your hand. My colleagues and artists will help us to moderate and orchestrate this. Apart from that, the ones who are joining us online, please use the Meetup platform to ask questions, share your thoughts, comments, and jump into the discussion, at least as artists mentioned, in this multiverse or metaverse environment. So Robert, I will want to start with you. So your whole presentation was around sensing and validating and checking the product quality, checking the product properties, etc. And one of the things I wrote down from your presentation was that do not rely only on machine data, only on static data or episodic data, but rather than obtain real-world or real-life data as such. So my question would be, we will be speaking about urban solutions, smart city, which is a dynamic thing. So once we were coming to the venue, we were riding a bike or driving a car or doing something, which is a dynamic environment. So how such examples of your presentation can be can be represented in the dynamic environment as such?
All right, good question. In fact, really the technologies and the application examples we at Resent are dealing with, they are not so easily to be transferred in exactly this dynamic environment or into cities, smart cities, dynamic products during application. There is a specific term, it's structural health monitoring, SHM, covering exactly this topic of monitoring the quality or monitoring potentially occurring flaws or defects during the lifetime or during the running time. I guess the people from Formula One will perhaps also deal with this. I know it from aeronautics, where you have structural health monitoring, so sensors embedded into the structures to really be listening and sensing during in flight, for example, and you see or you monitor any cracks exactly when they appear or when they come up. So we in our business, we are really integrating our technologies in the manufacturing process. Mm-hmm. But there is one other application connected to smart cities. Quite a set of the technologies we are doing research in, or where we are working in the application, is also applicable for environmental monitoring, for example, in cities. So if you want to get information about air quality or pollution or any, I think it's the best example is the air quality, where really we, with our infrared spectroscopy approaches, can apply these technologies. And there are many other technologies from the same subset of non-destructive testing, mainly based on cameras, where very many applications are realized in the last times for smart cities. So everything is covered with cameras. You are always watched by cameras, and the information that is being pulled out of all those video streams is much more than anyone might just think of.
Sure. So basically, it's about the symbiosis of different systems and different layers. So applying sensors and wireless sensor networks, or Internet of Things, the word we do love, to make the environment smarter and collect data to assist also your business in while validating in the manufacturing side. But switching back to switching forward to Vishal. So you mentioned about AI in cars. So basically, as I might call the car that you're developing and the software that you develop, and the car is smart as such, am I right? So basically, as I might call it, this is a symbiosis between the driver, not the driver, the passengers.
Yeah.
The passengers and the cars. So everyone is the passengers, as I mentioned in your presentation. So how can we provide this, dynamic monitoring? So you mentioned about guide monitoring, the way how your the driver looks or the owner looks. So what are the examples, and what steps should be done to make the car even smarter?
For example, Audi is also looking into communicating with pedestrians. One good way is to let pedestrians know that a car is making a right turn. And a car would be considered smart if it already gives this information to someone who's waiting at a junction, like a pedestrian who's waiting to cross the road. And something that I know is we use light projections, which will be on the road, like signs which would be sent by the car, put on the road, so a pedestrian can actually see that the car is going to make a right turn and convey some other information to a pedestrian, for example, like, hey, this car is actually going to turn right. Not to a pedestrian, but a cyclist who is also trying to cross the junction. So that's one way a car could be smarter, not just for people inside, but also for people who are outside.
Okay, and how about the dynamic monitoring of the passengers themselves? How to make the passengers, happier through the sensor data, or how to sense that they are feeling comfortable or feeling safe? Are there any vectors of development, to also sense and correspond, car data versus passenger data into, a more detailed picture?
Yeah, well, when you have cameras inside a car, you can basically monitor different states of the passenger. So you can see if he is in a good mood. Just to give you an example, if you can check a person's mood and probably change the cabin lighting in the car, just to give him a pleasant feeling. If he's stressed, probably this ambient lighting is gonna change his mood once he's in the car. So that's one way that you can use a sensor, which is a camera in this case, and analyze how the passenger is feeling and change the things that are inside a car.
So we can also adapt the music or driving regimes.
Yeah,
whether
you can
listen
change
to the blues or death metal based on our panel discussion
based
results.
on your mood.
Okay, good. So going to Paul, so you were presenting, the Formula One, as artists mentioned, Netflix top episodes currently, but not only, from times of Netflix for sure, also beforehand. But you were mentioning that, it's a very dynamic and very, interesting sphere with a lot of crashes as such. So do you apply any, dynamic monitoring mechanisms apart from, the car coming to the box and then you say, oh, the wing, is broken, we should fix it or glue it or do anything that you mentioned?
So as I said, there are quite a few ways to monitor the performance of a part and whether it's still fit for purpose. Preemptively at the design stage, we do tend to associate a lifespan to a part, and after a certain lifespan, we will go through procedures like NDT, which Robert has detailed quite specifically, internally to be able to see if a part is still fit for purpose. A lot of the times, these aren't monitored in situ per se, apart from specific parts like the engine, which aren't necessarily composites. So we don't necessarily do some active monitoring of composite parts, but we do reactive based on crashes, impacts, any visible damages, any predicted damages based on life cycle and use, or anything like that.
Okay, so basically we started speaking about, sensing, and before we move a little bit, deeper, I would ask the audience, if you have any questions, please raise your hands or use our internet platform called Mito, and my colleague artist will be very kind to read the question loud or, help you orchestrate with the mic and moderate the questions from the audience. But basically, we touched base about the, the topic of the sensor. Meanwhile, people, are preparing the questions. We touched base the topic of sensing, and based on, from sensors, we generate data, and data, I assume so, I really hope so, makes us smarter. At least the systems make smarter and more intelligent. So coming back to Robert, who's online with us. So you mentioned the use cases like with smart packaging and the thickness of the layers, 10, 11, or 9 millimeters, which is where is this golden standard to make, I don't know, the cheese, be good for a longer period of time, as an example. So through the validation and sensing, do you also apply any intelligence, or do you see that intelligence is being applied by the clients of yours to actually adapt, in more proactive manner to the thickness of packaging, as an example, or any other, solution being developed?
I'd say when it comes to intelligence, we have two approaches. On one hand, we need quite a lot of intelligence and also working with artificial intelligence today more and more to really get valid information out of raw sensor data. So this is one point where we apply an intelligence. And yes, definitely, by the data we generate, we try to give intelligence or the ability to work intelligent to the process owners. As you mentioned, this example of having 10 micrometers as the golden standard, typically a technical process will never be completely 100% in its perfect line all the time during 365 days of production a year. So you will always have up and down movements. This means you have to be, if you have to be always above 10 microns, you have to be on the standard setting for your process, more or less at 11. That also, when it comes to the phases below your target value, you are still beyond 10. But if I can help with better inline sensing to have a better control, then I can narrow these margins that have to be calculated into the process control. And this is the way we help the process owners to be more intelligent, I'd say.
Thank you. So there are different examples how based on data we can act better. One of the examples is a company Sandoz from part of Novartis. Basically, they also based on data, by changing the form of the pills, they increased, both the acceptance by patients as well as the revenues as such. So basically, testing and acting on data can be very straightforward in one dimension, or a little bit more complex. But Vishal, you mentioned about once again, gathering data, user experience, and adapting the experience of driving or safety based on data. So the smart car should act based on data, and it should act right.
Yep.
So what is right? Let us dive a little bit deeper in more philosophical aspect. There is a famous moral machine by MIT, that was published, and the big question there is how we can define something being smart in situations where not all humans are, straightforward with a certain answer. So how do you deal with such, dilemma as an AI engineer?
Yeah, you have this classic dilemma problem if you want to drive over a child or if you want to drive over 3 passengers on a different road. In terms of AI models and having these regulations in place, I guess Europe is doing a good job there because we are trying to regulate the development of AI, starting at the basic level. And for a car, I guess it needs to be really explicit. All these decisions that the car makes has to be really explicit to the person who's sitting inside as well as to someone who's on the street. I remember reading an article in the recent times of autonomous robotaxi, which just ran away from a police inspector in San Francisco, I believe. So in such a case, the police inspector who was actually looking at the car because it was driving without its headlight in the night, he was approaching the car and the car just sped away from him, an autonomous car. So in such a situation, the police officer doesn't know that it is an autonomous car, or of course he can make it out because of the different sensors that's around the car, but there's no explicit information that's given by the car to the person outside. And if such a situation happens to someone who is getting driven, the car has to give explicit information that something is malfunctioning and it has to pull over to the side if some system is not working and so on. So I think one way to let people have this confidence in the systems is by explicitly giving them all these information.
Okay. What do you think about the term? You mentioned artificial intelligence. Maybe we can call it augmented intelligence as such. What do you think about the aspect of, maybe adapting to the driver's, personality as such? If he is, an aggressive driver, then, car should be augmented to his profile or vice versa. I've read about I think it was Daimler, so Mercedes-Benz, they stated that in a crash situation, they will always put, the driver as a priority, so not vice versa, which is, which is a good sales point. If you buy a car, for 100K euros, you most probably would like, to be safe. But what do you think about, augmentation with the driver as such?
Yeah, in my talk, I also talked about personalization, right? So you feel really connected to the product when the product can actually customize itself according to your user profile. So if it's an aggressive driver, I don't think so there would be a function that would make the car even more aggressive. That's not the point. But I guess you would try to attack non-critical features. For example, you could personalize the interior of the car based on this person's mood, rather than increasing the horsepower just because this person is aggressive and wants to drive faster. I think we would mostly be attacking non-critical features rather than safety-critical features like speed or power of the vehicle. So that's one way that AI would be would help.
Sure. So if we were talking with Robert about very small measurements like micrometers, etc. But coming back to Paul, F1 is all about speed, seconds, or maybe even milliseconds, and technique, and basically it's a feeling of the driver of the car itself. So apart from what Vishal mentioned, that it should be augmented. I really think can envision that Formula 1 car and the Bullet should be augmented to its drivers. So do you have any vectors of personalization per se to the pilot, and also measuring his feeling of the car, whether it's right or not?
I will say that a lot of systems related to driver control are adapted to the driver itself. So the seats are specific to the drivers. The steering wheels sometimes are programmed slightly differently. The power-assisted steering systems are tuned. The pedal movement and resistance is going to be adapted to the driver. So yes, there is quite a bit of personalization even while the driver is actually driving the car. However, there are lots of regulations against augmented driving and further development, because there have been a lot of breakthroughs in the past, technological breakthroughs, that help the driver drive faster, or driver assists, and these are banned to keep the driver focus in F1 and avoid completely removing the human input in F1 racing.
No, that's very interesting, especially
just wanted to add something. It would be interesting to actually understand which Formula team that a user is actually supporting, and then change the interior of the car rather than making the car faster. So if someone is actually supporting Alpine, or if someone is supporting Ferrari, then what are the non-safety critical features that you can change in the car.
No, that's very interesting, especially if we can combine this with biofeedback as an example. Like in e-gaming as an example, they're using EEG sensors to train the gamers and also adapt the experience. Maybe something like that can be used in F1 as well in some day. But you were mentioning, like, coming back to the application to the urban solutions as such. So you mentioned that that you stress test all of this parts of the car for sure, and I think in some cases Robert can be of help to such testing. So the symbiosis can happen there. But whether we will find this point in the time when such things that you stress test and design and develop will be included in the cars Vishal works with?
Well, again, when we're talking about the cars that Vishal works with, we're talking about high-end automotive. We're talking about the top-of-the-line Audis and intelligent cars. And these do tend to use very high-end materials, either for lightweightness or strength or anything like that. And they tend to be quite common. I will say that high-volume manufacturing is quite different to F1 manufacturing, whereas the high-volume cost reduction and those types of parameters will be prioritized over lightness, quickness of turnaround, and those kind of factors. But I do think that testing, material development, and structure development will be very useful in automotive industries in the near future.
Let's talk more about the application. So going back from software development company, or or the lab, or the place the workshop, to the urban environment. So Vishal, what do you think? So what should be and how should be the urban environment adapted? Like the streets of Riga we saw. What should we put there to help you guys put AI first, or AI-centric cars on the road faster?
Yeah, like I think one of the most important things that you need to consider for a smart car is also its communication with infrastructure around. Okay. So vehicle to infrastructure, or vehicle to X, is one of the main topics that people designing smart cities take into consideration. So it would be interesting for a car to actually communicate with the parking lot already about its arrival, and the parking lot giving an information like, hey, you have a spot on the 3rd floor on this place. The first step for making a car and a city smart would be to have sensors at different places. Before I forget my line of thoughts, I just wanted to also talk about this decentralized wireless network that's actually getting set up in different places to support such smart sensors that you can put across the city. We have all seen these smart not smart e-scooters, but e-scooters that are going around. And one of the ways to actually locate these things would be using these decentralized networks. And Helium, I'm not sure if you've heard about this blockchain-based token. They have a really interesting business model where they incentivize us, normal users, to set up Wi-Fi hotspots at our houses and wherever you want to set up one, and you direction the network in a specific area, and different end devices can use this internet. So you actually get paid by the proof of coverage that you provide as a household. And now different sensors can use this network to communicate with each other. And I also read that Hong Kong tries to monitor air quality at different places and try to improve that using such a decentralized wireless network. I think just to make the city smart, you need to have such sensors in place. All these sensors need to be connected in one form or the other, and such decentralized frameworks would speed this process up. Because you don't need specific sensors, like the modem to be inside the end device for the device to be connected to the internet. Yeah, that's something I wanted to mention also about making the city smart.
Yeah, so the centralization of computing and also, data gathering and intelligence is quite impressive and tremendous topic. So once again, dear audience, if you have any questions, or artists, do we have any questions online?
We have a couple of minutes left, so this is the time to raise your hands if you have a question.
Nice.
Yes, there's a question in the second row. Let's get a microphone there. There's a question in the last row. Let's get the second one there. Quick questions, quick answers. We have a few minutes.
Hello? Hey, so my master's thesis was about smart homes and semiotic components. My PhD dissertation is about the design of interoperable techno-living spaces. So it fits into this gestalt of smart city. But one of the questions I wanted to ask y'all, is there not a better terminology to use rather than smart object? Like, in the future, are we going to be smart humans because we have some sort of technology integrated into us? Or is smart, essentially, is it purely a marketing tactic, or what's the actual connotation behind associating with smart?
Let's run a quick run, of a feedback. So Vishal, let's start with you.
Yeah, I think we should definitely have a definition for the word smart, like why you call a sensor smart or why you call a network smart. At the moment, I think when you call something smart, this eases an operation in some form or the other. Like you can quickly communicate or interact with the sensor. That's one reason why you call something smart. But I think there should definitely be a specific definition why you call something smart, not just because it is an iteration or an improvement over the previous system, but there has to be a benchmark of some kind. I totally agree that there has to be a definition.
Great. Robert, quick note from you.
It's an interesting question, and I have no idea about the future. I just believe the origin of the smart might have been that things tended to become as smart as humans. So I don't see the term of smart humans later in the future. But no idea what might come there.
Yeah, Paul.
Yeah, I'm going to echo what Robert just said. I don't personally think it's about smart humans or smart integration into society, but it is smart machine learning, artificial intelligence related to smart, which kind of helps us in our day-to-day life and makes not necessarily us smarter, but provides us with help in a smart way.
There is a term called biopunk or cyberpunk, with the biologically enhanced through the, genetics or cyber, if you're speaking of ICT. But there was another question.
Hello. I have a question regarding to composites. I've been into this for about 20 years in a hobby level, starting producing the sport bike fairings for myself, and now I'm doing this for my kid. As I see, not much has been changed for this time period. I would like to ask, are there any samples or examples of smart fibers where sensors are built in on purpose at the level of producing these leaves of fibers?
There are different places across the car where sensors are integrated to monitor the fiber performance and the characteristics and monitor the overall performance of the car. Unfortunately, we are relatively limited in the types of materials that we can use within F1. And there is quite a bit of regulation given by the FIA, the Fédération Internationale de l'Automobile, which does limit us in what kind of materials that we can use. But we have looked into different types of manufacturing with much more intelligent, I would say, composite structures.
Thank you for the questions. Thank you for the discussion, taking care of the time and letting artists to hop back on the stage with next speakers. So just to quickly sum this up, we once again touch base on the topic of communication. Once again, how we can communicate the objects or devices or humans can be in symbiosis with devices, and how we can do this participatory sensing as such. There is a term like that. So how we can interconnect different devices or also us all together to collect data and act based upon it. But thanks a lot. Thank you, Vishal. Thank you, Paul. Thank you, Robert, for being a part of this discussion. Thank you so much. Wish you a great day, and good luck.